Hello, this is Keith Kreischer, the Executive Director of the IoT M2M Council, or IMC, and it's my pleasure to welcome you all to this webinar on ultra-low power IoT brought to you by the IMC. I certainly hope everyone joining us today is staying safe and well in these interesting times. We'll dive into our feature panel discussion in about 2 minutes. The topic for today's panel is low power IoT, how it's helping with device life cycles and saving on connectivity costs, among other things. And the panel will be moderated by our good friend Matt Hatton of Transformer Insights, one of the best known analysts in the IoT sector. The panel is going to feature experts from Core, Kyocera AVX, and Vodafone IoT for the next 45 minutes or so. We also encourage our audience to join us for another panel that will follow immediately on the heels of this one. The subject for that panel is over-the-air firmware updating, and it'll take place at the top of the next hour. You can find a link to that session in the handouts section of this interface. I'll pass things along to Matt in just 1 minute, but first, before we begin, excuse me, I also wanted to cover a few housekeeping items. This webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. An on-demand version of the webcast will be made available later today and can be accessed using the same audience link sent to you earlier. Also, materials from the presenters are available in the handouts section of this webinar interface. We encourage everyone in the audience to check that out. If you have any questions during the webcast, you can submit them through the Q&A box on the right side of your screen. The presenters may answer questions at the end of each session, but please feel free to ask questions at any time during the presentations. I'd like to emphasize this. Please rest assured that any unanswered questions will be responded to offline. If we don't get to you during the session today, we keep records of your question. Those records are associated with your registration, and we will get back to you. We'll do that during the session if time permits, but if not, then we'll do it afterwards. For those of you that don't know the IMC, perhaps just a quick word of introduction would be a good idea. The IMC is the largest trade organization dedicated to the global IoT sector. Its membership is comprised of 28,000 rank and file adopter members who are individual enterprise users, product makers, OEMs, and apps developers that actually deploy IoT solutions. The IMC Board of Governors includes 30 or so of the most influential IoT technology companies, and they provide solutions for connecting remote devices in the form of hardware, software, and connectivity. We encourage anybody attending today to check out our website, iotm2mcouncil.org. On that website, you'll find information about our latest initiative. That is the Joint Task Force on IoT Security, and the IMC formed that with a global certification forum. There's lots going on in the area of IoT security right now, but what makes this initiative unique is that it covers not just IoT devices, but also networks and cloud app platforms. So please look for that on the IMC website. Moving on to today's session, the mission of the IMC is to accelerate the adoption of IoT technology for the public good. And we look at this session on low power IoT as exactly in keeping with that mission. And now it's my pleasure to introduce Matt Hatton of Transformer Insights. Matthew, good afternoon. I think you're muted, Matt.
Not my doing. I think I was muted, but I was just good start. Off to a flying start.
No worries. Hey, take us away.
Yeah, that's awesome. Always a pleasure to join these IMC sessions. I was thinking about this low power theme, and really, if anything, it's the unsung hero of IoT, enabling a huge number of use cases that might not otherwise have been possible. Today, we're going to be talking about a whole range of elements of the IoT stack, from devices to connectivity to applications, and how power consumption might have an impact on reducing the barriers to entry and driving a lot of adoption. Historically, we've talked about something called the thin IoT stack at Transformer Insights, which is a set of technologies which enable more and more adoption of IoT, and that really focuses in on two things: one about reducing costs, and the other one's around reducing power consumption. So we're going to be zeroing in on that power consumption topic today. As is usual with these sessions, there's a brief opportunity right at the start for each of my speakers to offer some introductory remarks. Well, introduce themselves and offer some introductory remarks. So we'll go through those, and then we'll get on to a set of structured questions that I've got. And please do drop questions that you might have into the chat, and we'll get to those as we can. I should introduce my first speaker. First up is Scott Lemon, who is the Senior Director of Market Engagement and Innovation at Core. Over to you, Scott.
Yeah, good morning. Really appreciate the opportunity to be here and chat about this subject. IoT is definitely something that's of high interest to me. So a little bit about Core. At Core, we're one of the world's largest MVNOs. We actually need to update this slide. I realize we're now at over 20 million IoT managed connections. So we've got distributed access all over the world, about 3,600 plus global customers. And we've got an employee force that's actually also worldwide. We provide connectivity for IoT devices over cellular networks all over the world. We have partnerships with 45 different carriers, hundreds of carrier networks all over the world, and providing coverage in 180, 190 some countries. So that's the foundation for what we're able to provide. But one of the things that we definitely recognize with our customers is that IoT is more than just connectivity. It's the full end-to-end solution and what's going on with the customer and what they're trying to provide to their customers. And so we also have services that we offer to help manage that entire IoT lifecycle and IoT application, from assisting in architecting and designing the IoT solutions to assisting in managed services to deploy. So both acquisition of hardware, configuration, shipping of hardware, things like that, to assist also with the management of the deployment, and then the scaling as things begin to grow. We definitely recognize that companies approaching IoT often look at it as a daunting task to get into, and we work hard to provide a full breadth of services to address and assist them in getting their applications out there and operating well. I'll hand it off to whoever's next.
Okay, thank you, Scott. And our next speaker, so let me introduce Carmen Redonda, who's the Global Marketing Director for antennas at Kyocera AVX. Carmen, over to you.
Thank you, Matt. Hello, everyone. So I'm part of Kyocera AVX. We are the Advanced Electronic Components Division of Kyocera, which is a Japanese company. Our headquarters are in the US, in the South Carolina, where we have sales around the world, as well as factories. Many different types of components, advanced electronic components, from capacitors, connectors, filters. I'm specialized in antenna. I'm an antenna engineer. So one of the topics we'll cover this presentation is about antennas. In terms of antennas, I would like to give a highlight about our footprint. We are located in 5 different regions with design centers, where we help our customers integrate an antenna. Despite or in difference with other components, antennas is not just a catalog component that you choose, but it needs a lot of integration with customers. So we have design centers in San Diego in the US, France, in Nice in the south of France, Taiwan, Korea, and China. And then we also have our factories in China, Korea, and Vietnam to support the production of our components. In today's topic, which is the ultra-low power IoT, I would like to focus on 2 different components which are very important in this topic, which is the antennas, of course, which is my specialty, but I will also would like to give some hints about super caps, and how this is helping in the power efficiency of IoT devices. Before entering into the details, I would like to give here a couple of hints about these components are helping extending the battery life of the IoT devices, but also helping in the relay connectivity, which it will, at the end of the day, translate into more efficient power and less consumption. So, as I would like to say, these are the superheroes which are hidden, and many times designers are not thinking about it. But yes, we'll come on later about that. Thank you.
Fabulous, thank you, Carmen. And to Larry Tahowski, who is the IoT Technical Manager for the Americas at Vodafone IoT. Larry, over to you.
Good morning, thank you. Yeah, this is Larry Tahowski from Vodafone IoT. I head up the IoT and technical initiatives for the Americas. And today I wanted to give you just a brief overview of Vodafone and also the LP-WAN technologies that we work with. So I call this slide by the numbers, and I show this because I think it tells a pretty good story of Vodafone. So right now we use about 760 plus networks to connect over 215 million devices globally. And those devices are deployed in about 180 different countries. Then you see 130 here, 130 networks, LPW networks that we use to connect those devices. And that number right now is growing aggressively as we speak. And then finally, the number 11, which is the consecutive number of years that we've been a leader in the Gartner's Magic Quadrant for IoT connectivity. And to me, I think that really shows that, you know, Vodafone IoT not only has a vision of what IoT connectivity should be, but we've done a pretty good job of executing on it. Next thing I wanted to talk just a little bit about is our low power wide area networks that we work with, or AKA machine type communications. This is where we use a sliver of spectrum that is dedicated to low bandwidth devices. Think battery constrained devices like, you know, I think water meters or gas meters, global trackers, or wearable devices. These technologies not only provide a simpler radio, but also increase penetration of signal as well as power saving attributes. There's two particular technologies that we work here with Vodafone. One, NB-IoT, or narrowband IoT. While it's largely deployed, we see a lot of deployments out of the EU for battery constrained devices. NB-IoT is extremely well used for devices that are not on the move, that must consume little bits of power, and then also transmit small amounts of data. So when I think of NB-IoT, I think of water meters that need to last in the field for like 15 years. We also deal with LTE-M with our LPWA footprint. It gives their higher bandwidth and allows for mobility, so thinking trackers or wearables, and also has power saving attributes similar to NB-IoT. But technologies, both of these technologies are lower in cost than general LTE technologies, which makes it attractive for mass deployments. A couple of the emerging technologies that we're looking at is obviously RedCap. This will be kind of a bridge between 5G enhanced mobile broadband and classic LTE IoT deployments. Ideal for use cases for, you know, for IoT use cases that need more bandwidth that LPWA doesn't provide, but they don't need the full capabilities of 5G SA. It reduces bandwidth, but also lowers power consumption, simple radios and antennas, and I think it'll make it attractive for a lot of IoT use cases that we see LTE address. And then we also see eRedCap on the horizon that uses even less bandwidth and less spectrum and further simplifies the radios and antennas, uses less power and lower cost components. So I see this probably addressing the Cat 1 or the Cat 1 bis type of market. And I don't see at this point, you know, LTE-M or NB-IoT really competing with these new technologies that we see on the horizon. I'll go ahead and hand it off to you, Matt.
Okay, thank you, Larry. If I can have all the panelists back on deck again. And there we are. Awesome, thank you. As I mentioned, I've got a series of questions, and as I specifically mentioned, those will go through what I see as being the IoT stack, the various elements of the IoT stack, and how power consumption, and some of the technology developments there are helping to sort of open up the opportunity. I'll go to a person with the question, but please everybody contribute. Feel free to jump in as you see fit. I want to start with hardware. That seems like the obvious place to start when we're talking about a stack. And Carmen, I want to come to you, because obviously you open things talking about specifically antennas and then alluding to a few other hardware related elements. So what can really be done with the hardware components to address questions of energy optimization? You mentioned about antennas, but I mean, how specifically, and also other areas where you see hardware developments having an impact?
Yeah. So Matt, I like that you say that when you start in the stack up, so to the obvious, we start with the hardware, but if we talk about power consumption or how to improve it, I think that's the last thing that people is thinking of. Well, of course, the module, but I will say that in general, in IoT, when our customers are discussing what protocols to use, because they have different power consumption depending the protocols, module, as I mentioned, and also even the firmware, which, how much your device is sleeping. But very few people always remembers about hardware that can help about this efficiency. And one of them obviously is the antenna, because if you have an efficient device, it means that you will use less power to transmit, and I would like to give the use cases of customers that are designing trackers. So especially with the miniaturization of devices and having more technologies inside, the efficiency of these devices is going down. So most of the times when they can, they use standard products, but many times they need to go into customization because they want to make the most efficient part. And if you're looking about accurate location or transmitting even data, if it's very easy to connect, but if you miss the connection, you will keep retrying to connect, and that will consume obviously the battery. So I think this is something very important, and as I mentioned, we really help our customers to optimize the whole device. It's not about putting the antenna and it connects. It's very easy to connect. The challenge is to be in what environment you are, when the real little connectivity or coverage you have, that's when the real difference makes of having a good antenna in your device or having an antenna that just connects. And very quickly also, as I mentioned about the super caps, so I'm not specialized on that, but I've been talking sometimes because I'm very involved into the IoT market and with customers. The super caps in terms of power management, it has a very important role in IoT because let's put the example of smart metering. Sometimes there is some peak of power, that comes. And when you combine the battery with a super cap, these super caps can really help to extend the battery life for those devices. And we are talking that in IoT, the goal is to have 10, 15 years of lifetime of the devices. And with these super caps can really make the difference to extend the battery life and obviously the low power consumption. So this is the kind of examples of how big important mission these components are doing and differentiating from device to device.
Can I just ask a quick follow-up question on that super caps question? Okay, yeah. So this is effectively an incredibly efficient capacitor, or I mean, how is it helping to reduce that power consumption? So
they have a capacity of very fast charge and discharge. So compared to the batteries, if the burst goes directly to the battery, it will drain quite a big amount of this battery capacity that you have. In the other hand, when you go through the super cap, you have a much faster charge on discharge. So you will be able to maintain this peak without really affecting the battery lifetime. And then we will, again, with the time, we'll charge again. So this is how it's helping to maintain the power.
Okay, fantastic. And if I can sort of summarize, there's a question of, okay, you've got components which are inherently low power, but actually it's probably more about quality, because then you don't have to keep retransmitting, you don't have all of those issues of dropping out and packet loss and so on. So would you say it's more a quality question than it's necessarily a nominal power consumption question.
Yeah, it's not about the product itself, of course. It's about how efficient you are, right? Because and I guess it's another technology, especially the new ones when people are making trials. I mean, sometimes you see customers just having even to connect to satellite, just put whatever wire, no, and they say, oh, it's connect in my laptop. I can do the changes. It's like, yeah, but one thing is that you connect, but the other thing is like, can you maintain the connection? You don't need to retransmit. Can you in different orientations, if you clamp close to the body? So there are many different use cases where if you don't have an efficient antenna, you will lose connection, and that means that you will need to reconnect again and use more power, etc. So as you mentioned, is quality, but also about the integration is very important to be aware of the challenges, how the body is affecting, how the size is affecting, to make sure you have the right size of your device. Sometimes few millimeters can really make a difference about something which is working and something cannot meet the minimum performance. So with IoT, I think we are playing with in the limit of let's say of the specifications, because you want something that of course works fine, is reliable, you can meet the specifications, but at the same time you want something which is low cost, something that is small. And so you always need to play with this parameter to make the good enough, but it's good to the quality that we want to. Not every good enough is sufficient.
Yeah. Okay, good. Scott, Larry, I don't know. I mean, obviously, we'll get on to talk more about connectivity with you, gentlemen. But thoughts on this hardware topic? I don't know whether you've got anything to jump in with. Scott, maybe first. You seem to be muted, Scott. I don't know.
Yeah, we can't get the.
Yes.
Oh, there we go.
So yeah, no, I think it's very important when you are looking at these devices that all of this in hardware is probably the foundation of a low power device. There are modules that you're going to want to consider. How many additional components you're putting on the board? Are you actually running your application on the cellular module rather than adding a separate MCU? And then it's, and I'm sure, Larry will touch on this too, as he mentioned, what low power module protocols are you using? Are you using LTE-M? Are you using NB-IoT? Cat 1 Biz has become more and more popular. And that relates directly to the module selection, and then looking very carefully at those modules and what their power consumption is.
Quite. Well, we'll get on to talk about the network. I mean, obviously there's a component element to the network selection as well, which they sort of go hand in hand, right? But specifically on the hardware, Larry, if you've got something you wanted to jump in with on the hardware.
Oh, it's gonna just on top of what Scott said there, antenna efficiency in TIS TRP is terribly important for power efficiency. If you don't have a antenna that's efficient, well, it's really hard to have a low power battery efficient device, power efficient device. So it's a critical component, something that we look at with our customers when we're developing a device.
Right, we've got a lot of things to get through. Let me move on to the next topic, and Larry, I'm going to come to you first on this one, and that's also a component-related topic and very much flavour of the month at the moment in anybody who's looking at cellular-based IoT, and that's around eSIM, EYCC, remote SIM provisioning, kind of a bridge between the topic of connectivity and hardware. Customers, I think, probably should be thinking about the power implications here as well, right? Because there is some drain associated with doing remote SIM provisioning, profile switching, that kind of thing. Want to get your thoughts on that one?
Sure. Yeah, absolutely. There's a new, EOICC standard, coming about, which is what we're calling SGP.31.32, and allows you to go ahead and remotely, provision and manage a profile on a SIM. And, so obviously a lot of our customers are looking at that because of the flexibility to be able to change MNO profiles remotely, but it also does, come as a cost, right? especially in a battery constrained device, to go ahead and download an MNO profile on that device. It takes power, as well as making the decision on when you want to switch profiles back and forth. So we're working. Obviously, it's a pervasive technology that's coming up, and we're working a lot with our customers who do have power constrained devices on solutions, on maybe even pre-downloading at manufacturing, dual profiles, and then moving the decision to use a profile from the SIM to the device, because the device knows more about its power consumption and how it operates. So there's a couple of things we're doing there, and then also looking forward to kind of the SGP 4142 standard, which should allow at a factory, at an OEM factory, to be able to download profiles at manufacturing instead of at the SIM manufacturer. So that's an interesting technology that we're seeing on the horizon as well.
Yeah, that was one that I was gonna raise if you didn't, because what we found with SGP 3132 is that there's quite a significant battery drain, but if you can, and so you probably don't want to put those profiles into place when the device is already in the field, and doing it earlier using that in-factory profile provisioning that's part of the 4142 standard does absolutely make sense, particularly for things, well, all of the use cases that we're likely to discuss today, but things like smart water metering and gas metering and so on. Scott, I wanted to come to you on this one as well, because obviously cellular-based connectivity is your bread and butter. So thoughts around this power consumption topic, for specifically around eSIM?
Yeah, specific to eSIM, what's interesting is there is the chip itself. There are things like the profile downloads, but one of the things we're recognizing is it's even the importance of the profile portfolio. Like, what profiles are you using? Because that can directly relate to the latency of the connection. Latency being the speed at which you can get your data or even registered on the network. And the longer the radio is alive having to communicate, the more power you're consuming. And one of the things we see, coming with eSIM is that ability to put local carrier profiles or local profiles down on the device that might give you better responsiveness from the network, shorter registration times, lower latency for the device to get onto the network, while still having that ability to switch profiles to maybe a roaming profile to get over to other carriers when connectivity is missing. And so it's not just the eSIM itself, but it's that profile selection that also starts to become important to consider, particularly on these ultra low power devices.
Yeah, quite. And one of the things that we've noticed as an evolution over the course of the last probably 10 years is, historically you could kind of send any device onto any network and they perform with within similar kind of parameters. But increasingly, it does matter which network you're putting devices onto, and the performance will vary quite a lot. And so having a range of options is often a significant thing. I've not really thought about it in the context of power consumption before, but it is a relevant thing, clearly.
Yeah.
iSIM as well, I wanted to raise. How does that sit relative to eSIM, while we're talking about the sort of componentry piece of it as well? Is that a power saving? In fact, is eSIM as a piece of hardware a power saving? Larry, maybe I'll come to you on that one first.
Yeah, sure. iSIM's, honestly, a really exciting technology that's out there, because it takes all the components that you need to connect an IoT device and puts that system on a chip, so a SoC. So one of those components that's on that chip is the iSIM that resides in a secure piece of memory. Why it's really interesting is, one, by taking away that component of a SIM card reader or an eSIM and putting that on a piece of silicone, it does save power, right? And it also, argues that it makes the whole solution much simpler, because I'm only now worrying about a system on a chip that's embedded into a module that can control pretty much everything that I need to do for a simple IoT type of device. And currently, ISIM, those get loaded as a blob at the factory. And we'll see now kind of the advent of, I think we're calling it IEUICC. So to add that remote SIM provisioning component now to the ISIM, which again further simplifies the connectivity of lightweight or battery constrained IoT devices.
It certainly does, but when we're starting to get into 6-letter acronyms,
yeah, really.
it is a good place to be for the industry. We'll muse on that a little bit. So it's a natural move from talking about the SIM piece, talking about the actual cellular technologies. And Larry, you kind of opened you kind of closed your opening remarks with some comments about the different technologies that are available there. I want to talk a little bit about that. You discussed some of the capabilities, but what about questions of harmonization, particularly because it's still quite a fragmented landscape for those specifically low power technologies, narrowband IoT and LTE-M, and that's even notwithstanding RedCap and eRedCap, where it's rather dependent on whether the operators have upgraded to 5G standalone. So I wanted to get a perspective on that, if we can.
Sure. Yeah, absolutely. I mean, we work with quite a few developers who will develop us, especially in the US, where these power saving attributes that I referred to for NB-IoT or LTE-M are fairly harmonized, right? With the major MNOs in the US. So if I'm relying on specific EDRX or PSM settings or high latency comms attributes, for one network, and then I go send that device out into the world, well, I can't really rely upon all those networks to be harmonized across the world. And so, we see, kind of a learning curve when we're sending one of those devices out into the wild of, how do you negotiate with a network that may not have the same settings as the home network or the network that you developed on to go ahead and be a productive device across the world. And since in the NB-IoT or LTE-M standard, there's no harmonized settings that are actually written there, so it's really up to the host MNO to set those settings. It's been a challenge.
No doubt. Scott, have you found the same thing?
Yeah, we're when I first got into some of the newer cellular technologies, I was a big fan of NB-IoT. I was doing some development testing, thinking, oh my gosh, this is wonderful. And until I found out, the global distribution of where NB-IoT exists is a little troublesome. And as our business unit was acquired by Core, getting involved with customers, we found the same thing. Customers hear the story of Cat-M, they hear the story of NB-IoT, and then when they go to do a global deployment, they start realizing that, it's not evenly distributed at all. Even within countries, we found places where Cat-M might exist in cities, but not in the countryside. And that has become a problem. Now, recently, we've seen more and more people moving towards Cat1bis. Qualcomm put out a great document on this showing where Cat1bis, because of the higher speed, can actually have a shorter transmit time than the slower speed Cat-M or NB-IoT. And in the end, you can actually be more power efficient. And Cat1bis also has access within the standards to PSM and EDRX. So it has this ability. Those are these timers that allow you to negotiate with the tower how long you're going to sleep. And even more recently, one of our partner companies that makes IoT trackers was just doing their analysis where they even found that just flat out shutting down the modem is often more efficient than using some of these advanced protocols because the negotiated timers are controlled by the carriers. And they might not give you good timer values that let you sleep as long as you could. And by just simply shutting down the modem, you're going to save more power. So all of this, just sort of, emphasizes the complexity of this subject. If a company is going to get into this and really be looking at these ultra low power devices, there is considerable expertise and consulting, researching that you need to do to really understand the depth and complexity of this.
A very wise man, a guy called Afzal Mangal, who knows a lot more about IoT than I do, has a chart of all the various different technologies with cost, power consumption, battery life, all of these various different parameters, and in every box in that matrix it says it depends, and that is the answer. It depends. It depends on your deployment. It depends on your use case, on the application, all of these sorts of things. Okay, I've got one eye on the time. Carmen, we've talked a little around cellular. I just want to give you the opportunity, if you've got some thoughts around the cellular connectivity piece, to contribute on that if you wanted to.
No, I think for antenna it also it depends. So I like this answer. I think it really, I mean, different technologies have different bands, different things. But from our side, the way we implement it, I think, is like looking at the really specifications and try to make the device as efficient as possible. And we see the characteristics of each device. You have protocols will use lower frequencies that they are maybe more efficient, but then of course you need bigger antennas, and it's maybe more challenging to have good performance. Other protocols use higher frequencies. So yeah, it's really our work behind. I don't think from antenna point of view we are just the messenger, we'll say, and our task is just to make it as efficient as possible, whatever the protocol goes inside.
Very good. One final one on cellular connectivity technologies before we move on. RedCap and eRedCap. Larry, you mentioned RedCap and eRedCap. Is it here? Do we have it? Is it are either of them really low power, wide area technologies like NB and LTE-M? What's the prognosis there for the next couple of years?
Well, Scott probably has some comments on that as well. But RedCap, I think we see, obviously being an extension of 5G SA. You don't need the full power of 5G SA or enhanced mobile broadband. So eRedCap's looking very interesting for LTE-M type of device, or sorry, LTE Cat 4 and above type of use cases. I think again, living in the U.S., deploying devices globally, we see 5G SA expanding much faster here in the U.S. just because of the cohesiveness of the networks. And we're seeing in Europe, 5G SA expanding at a slower pace. So the availability of RedCap, I think, for the next 2 years on a global footprint may be difficult to rely upon. All right, and so I think that's you're seeing. I think I read somewhere that it's growing 50% year over year, this 5G SA footprint in Europe, which means it's growing at a good pace, but it still has a long way to go.
Long way to go. Scott, I assume you'd echo that.
Yeah. Just I agree. I agree with what Larry said. We see it as a valuable technology. I think it's going to still be some time until you have a good even distribution of it globally. Particularly, those we often in the U.S. get a little biased where it's like we look at the country here and say, "Gosh, things are just going well," but then it's when you get customers who are deploying globally. But I think the other one related to low power is, again, as Larry's slide showed, you get with RedCap this higher speed connectivity, and people don't often think about the fact that the faster you can move your data and get that payload over and be done, the less power you consume. And that's sort of like with the Cat 1 Biz argument, that's a value point that's going to be there that I think as the networks get deployed, it will be good.
Okay, good stuff. We've reached about the halfway point in the questions, and we're certainly well over the halfway point in the time. But I'm going to go to one of the questions that came in on the Q&A, and I suspect, Carmen, this one related to the supercaps you were talking about, because someone's asking, can they power cameras? Was the question we got. I assume that's related to supercaps, but.
So I don't know if it's related to, because I haven't talked about it. Maybe I can introduce the topic, if Matt, about the energy harvesting, because I was talking about the power management of the supercaps, which is to extend the battery life. So, but when you say power cameras, I don't know if it means that to use the supercap to use the camera. So another characteristics and very important also for IoT that the supercaps is like they are acting as a power harvesting. That means that in applications that use, instead of getting the power from the battery, you can get the power from solar panels, to get energy from the sun, and from other kind of ways to get energy on it. And we do have projects where we have, like especially in the wild forest, like wild forest sensors for fires, or in very remote areas where you want to have something that is sufficient because they only send very few data, and using the supercap you can storage the sufficient power to be able to have a battery-less device, which is very interesting from power consumption for sure, but also for environmental, because batteries, they have chemicals, and supercaps is an electromechanical piece, right? So it doesn't. So I don't know exactly the answer because I'm not specialized on that, but I think if the camera is something, if it's sending data in terms of something happens sending data, it might be possible, but of course it's not replacement of the battery. So, but if you can send more information, I can come back to my colleagues.
I'm sure that will get circulated as a question. All right, let's move on to the next one. Non-terrestrial network satellite. So satellite connectivity is always an interesting one, and if you can reduce the power consumption related to satellite, that opens up some opportunities for connecting things all over the world. Carmen, I want to come with you first on this one as well, and then Larry, I'm sure you'll have some thoughts.
Yeah, so the satellite connectivity in the IoT again comes related to power management, right? Because it's been for many years satellite communication, and we have been doing antennas for it. Normally you have proprietary protocols, much larger antennas, you have more expensive modules and hardware. But when you're looking into the IoT, the NTN, which is thanks to the 3GPP release 17, when suddenly they start coming into standardization of the protocols of the hardware, right? It opens really a big, broad, let's say, opportunity, a lot of opportunities, right, for this market. Like I've seen that, like they say, 70% of the world doesn't have terrestrial connectivity. So you can imagine, especially in South America, between oceans. There is a really big opportunity there. Now you say you use the same hardware, just firmware updates. Well, for antenna, it could be the case, especially when you use hybrid devices. You can use the cellular antenna. For the S-band is already covered. For the L-band, you need to adjust it to be able to cover those bands for NTN. But the reality is that the satellite signal is circular polarized. So yes, you can receive the signal as the same as you can use your GPS on your satellite or your cell phone, sorry. But you will require more power, and it won't be the efficient way to get the signal. That's why we have been working on different solutions which are lower cost and have circular polarization. And also another important factor, Matt, is to see that you don't always have the satellite on top of you, right? So you have cases where even in geo satellites that you will think that is always in the same position. I can tell you there are cases where the geo satellite is in the upper hemisphere, and then you're in South America, and then you will have still lower elevation angles to cover. So we see we are doing a lot of innovation from the antenna side, and there is a lot of improvements that the antenna can offer in those cases. So it will contribute again to reduce the battery management or the battery consumption when you want to connect to the satellite.
Good stuff. We'll have to move on unless you've got a quick comment on that, Larry. related to satellite or no? Okay, let's shift the discussion onto non-cellular technologies. And Scott, I wanted to come to you on this because I know that Core is making quite extensive use of LoRaWAN, some other protocols for your Omni Hub and other hardware that you've got. So what's the thinking of that? That extending to devices that might not otherwise have been supportable via cellular because of power consumption issues, or what's the thinking around the architecture there?
Yeah, so this would be talking about sort of hybrid networks, so where you're combining other technologies, wired or wireless, with cellular, in order to be able to cover larger areas or connect to different kinds of devices. So, for example, even here in my house, I have very inexpensive Bluetooth beacon sensors that are talking Bluetooth. I have numerous of them spread throughout my house in different rooms, going back to a cellular gateway, where then I'm backhauling the data over cellular. And what it's doing is giving you that bigger reach, covering a wider area, instead of having to put a cellular device in every room and thinking about it in that way. Or in agricultural applications, we have customers using it there with LoRaWAN, where they've got the LoRa sensors spread over a larger geographic area, agricultural, multiple greenhouses, pulling that back to a cellular gateway where they backhaul the data. Some people doing similar thing with car lots. We have a customer doing that with automobile sales lots, where they've got trackers that are in each of the vehicles on the lot to be able to track where they are as they leave and come back to the property. Again, doing it where cost effectively they're able to monitor hundreds of devices close by to that car lot within a kilometer range or something, and be able to backhaul over cellular. And so combining the technologies like that, the biggest thing is you're getting that much larger reach of the actual sensor or transducers, coming back to a common point of communications.
Okay, so that's connectivity. And one other thing I wanted to touch on while we've got about 2 minutes left is we didn't quite get to the application and protocol topic as well, Scott. So top of that stack is the application logic. So and the protocols being used within it. So whether that's appropriate messaging protocols and so on. Big part, presumably, of considerations of power consumption is just making sure your application is built right.
Yeah, this is huge. I mean, this is where we find probably the least amount of knowledge. And, I think there's even generational knowledge that, people are used to using HTTP and JSON payloads and the things that modern developers use. And, I found a case with a customer where they were sending about 5 times the size of the payload than of the actual data. They didn't think about compressing data or using modern protocols to compress their data down as small as possible. In a similar way, it's even the retry logic that they use. If there is a connectivity issue, are they just waking up and trying and trying and trying, or are they doing, an exponential back off to allow the device to sleep and wait for connectivity to come back? There are carrier issues that occur. So there's many things just in what protocols are chosen, how they're implemented, how people encode their payloads, how often they send them, things like that many developers you find, and I don't know that it's their fault, but they're used to being on Wi-Fi in the corporate environment, testing out their device or doing something, and they don't think of the actual cost implication. And that cost is not only in dollars, but in power.
Completely. Larry, thoughts on that topic as well?
Yeah, I was just going to say, that what Scott's saying also, that intensifies when you're starting to use a low power network or even more NTN, right? Because not only are you have a higher latency for a geo, but you're also paying a lot more for that piece of data to transmit over the air. And so being very stingy on what you're going to transmit and how, it makes a lot of sense when you're developing towards those networks.
Yeah, absolutely. I'm gonna cheat and sneak in one question that's coming from a member of the audience. And this is a cellular-related question. I'm deploying globally refrigerant gas leak detectors, amongst other things. My question is, we saw AT&T discontinue NB-IoT support recently. In the USA currently, what's the risk that other carriers might discontinue NB-IoT support too? My experience is actually someone like Verizon has doubled down on it and is talking about maintaining support for quite a long time. So that's my experience. Larry, Scott, thoughts on that one?
I mean, from our standpoint, we're seeing globally, a decrease and dropping of support for NB-IoT. I think even China came out; they were probably the world's largest deployer of it, and there were some rumblings that China is now stepping away from NB-IoT. Although it's used now in the NTN networks, which is where I see the flip side of it picking up. The problem was that with NB-IoT, you just didn't have the roaming agreements and other things that were going on. It made it very difficult to do global deployments of NB-IoT.
Fair enough. Larry, final word to you.
Well, NB-IoT is alive and well in Europe for sure, because we got lots of meters connected to there.
Right. 20 million beacons for cars in Spain, right? It's millions of smart meters. So it's not.
Yeah, it's not going away. And I can't say anything about how the MNOs are going to, how they monetize that spectrum that's dedicated to NB-IoT. One thing I would say is looking at connectivity, if you have a MNO profile that can be able to access both NB-IoT off two different carrier footprints, right? That builds in some redundancy as well as some insurance. If an operator decides, well, I'm going to back off an NB-IoT or something like that. So I think it's important to, if you can, have that insurance of multiple layers of NB-IoT coverage where you're deploying.
Thank you. And on that note, I'm going to have to call things to a close. I've already been a bit naughty and stolen an extra couple of minutes of the session. Thank you to all my panelists. Thank you especially to everyone in the audience, those of you who were able to join us today. Please join the next IMC session, which is covering over-the-air firmware updating, which starts at 11 o'clock Eastern in just a few minutes, so top of the hour. You can find links to the registration for that session in the handout section of the platform. Thank you all. Thank you again to my panelists.
Thank you. Bye-bye.
Great. Thank you.
Bye-bye.